All right guys, Chris here with RackUp+Go, and thanks for tuning in to part 2 of our alternator install video, where we're gonna be wiring in this ARCO Zeus alternator regulator and wiring in the alternator directly to our battery bank here. So without further ado, let's get into it. All right guys, so we've got our alternator regulator here. This is the ARCO Zeus, and we're pairing this to an ARCO A275L alternator that's already mounted up. That was done in part 1. That's gonna be a 12-volt alternator. This alternator regulator is going to also include the extended van length harness. And so we've got 15 feet of battery harness and then another 30 feet for the alternator. This Zeus that we're gonna mount is actually, we're gonna kind of keep it around in this back area here. So the length actually for the alternator length to get all the way up to the front, that 30 feet is gonna be about perfect for us. The 15 foot, obviously we'll probably do some trimming because the Zeus will be living back here and we're gonna be making our connections directly to the battery here. So to make those connections, we have a select set of tools here, and this is probably what you're gonna need when you go to do your install as well. We've got some wire cutters, just a multi-bit driver, just in case you're loosening things on the battery terminals up. You need that. We're gonna have a multimeter, and this also has a clamp-on ammeter as well. A couple inline fuses. We're gonna be using one on the alternator field drive, and then we'll have one for the supply for the Zeus, which we're going to be integrating right into the distribution panel here. So we won't actually need this second one. This is already fused on here. But if you're tying in directly to the battery and don't have a distribution panel, you're going to want one of these. Various butt end splices, heat shrink butt end splices, some ring terminals. These are going to be for landing the connections onto either the battery or the alternator itself. We've got, a mega fuse here for our main positive cable, and this big honkin' 4/0 cable here that's going to be running directly from the alternator back to our battery bank. And considering this alternator is capable of 200 plus amps, that's why we're running 4/0 cable here. And then some additional shorter sections for grounding the alternator to the frame, and then also making sure the battery bank is also grounded to the chassis. So, and then as always, some zip ties to keep things tidy and clean. We've got our heat gun and various sockets we're going to need for undoing our battery cables, and then also working on the alternator and tying all that in. So, all right, so let's pop open our box to the Zeus. Right on top, we're going to have our ARCO Zeus regulator. We've got different ports on here. NMEA 2000 port and CAN bus RJ45, and that's what we're going to be tapping into. We're going to be utilizing this port today to work with the Go Power battery bank here. We've got our battery control harness and alternator harness connections on here, and then we do have this antenna. So this is going to be for the Bluetooth for programming, and then also this has pretty good range so that we're able to control the alternator regulator. We can be all the way up the front of the van. Put it in a generator mode, what have you. We'll show you that once we get this installed. Pull this out and get to our harnessing. So this is going to be our alternator harness, conveniently tagged. We've got a lot of cable here. This is going to be that 30-foot run. We're going to be running from here all the way up to the front. We've already got this connected. This is going to be plugging into our alternator. And this is going to be the field wire here and our stator or tack wire here. And we will have to clip this somewhere along here to put in a 15 amp fuse. If you're not pairing this with an ARCO alternator, you will need to clip these ends off and wire these directly into whatever alternator you're using. The Zeus does accommodate other brands of alternators. You don't have to use an ARCO alternator, but it is very convenient and very easy because you just plug it directly in. We've got our thermistor harness, so this is going to be measuring the temperature of the alternator. And then we've got a number of other wires in here. So this is going to be our alternator V positive, V negative, feature input wire. So we'll get that all tied in. This is going to be one of our thermocouples. So this is actually going to attach to the case of the alternator and give us the temperature. And that's going to actually fit into the plug here. Those will go in together like that. We have a second one This is another thermistor, and this one is for the battery bank. So there's our battery bank. However, we're going to be connecting this directly into the data feed from the internal BMS in these batteries. So we won't actually have to connect this on the battery harness. The battery information will be coming across the CAN network directly into the Zeus. So we'll get voltage, we'll get temperature, we'll get current in, current out, all from the RVC network from these batteries. So we actually don't need this one, and this will just go unconnected. We've got our ketchup and mustard here, or red and yellow. This is going to be our main power feed for the alternator regulator. One thing to note, if you're doing a different battery system, like a 24 volt or 48 volt, they do recommend using a 12 volt source for powering the Zeus. That should be a 12 volt feed to power the Zeus on this red and this yellow wire. So a few other wires in here that are going to be important for us. The brown wire, that's going to be our ignition sense. So the regulator knows when the vehicle is on and when it can start applying a field to start generating power from the alternator. Then we've got a lot of these other colored and twisted pairs of wires. This is going to be for the battery shunt, so to detect current in and current out. We've got our voltage sensing lines. We also won't need to hook those up because, again, we're getting all of that information directly from the RVC network. So a lot of these you can eliminate if you have a smart battery system. So if you're connecting to a Victron battery bank or Lithionics battery bank, or for instance this Go Power battery bank with the RVC network, and that battery information can be delivered over the CAN network or an RJ45 connection, the Zeus will read that and you can save yourself a lot of wiring. So we'll show kind of the idea of where these would normally go, where you'd have to install a shunt, but we can skip a lot of that because we're going to be getting all that battery information from the RVC or CAN network. There's our battery harness. There's everything we need. So we'll get going. First, we'll start up at the alternator. We'll start landing our main battery power connections, and then also the alternator harness, since there isn't as many wires required for that. And where we're going to be passing our wires through is the boot on the passenger side of the firewall, coming through there and then down to the alternator, because the alternator does sit on the passenger side of the engine block in the oil pan. So we're going to pass through in there, and for wiring in everything, we're kind of just doing a home run main line straight from that boot and then coming back to this battery bank. We're not going to be too concerned with where we're laying the cables. That's going to be up to you for your particular install. You can run it along the chassis down the outside of the vehicle, or you can bring it in through the same boot in the firewall and then pass it through, you know, over to the driver's side and then back to your battery bank. Or if your battery bank is on the passenger side instead of the driver's side, you can pass it right back through here. But mainly for this install, we're just going to be showing the wiring connections and then doing a home run right from there all the way back to this battery bank. So it's not going to look super neat and pretty, but you'll get an idea of how everything's going to get wired in. All right, guys, so this is the boot we're going to be going through. I've already taken the zip tie off of right here. There is like a little foam piece on the inside. I'll pull that out and show that to you. But our power cable and all of our alternator wiring is going to come right through this boot. And then we're going to pass it down into our alternator, which is right down there. You can kind of see the pigtail coming off the back of it. That's our Arco A275L, and that's where we're going to land all of our connections. So this is the foam piece that's on the inside. If you reach up into the passenger side here, you can pull that out of the boot, and then we're just going to set that aside for right now. Might be easier to work if you take out this section of the floor mat here. You'll notice here you got a fuse box label, some tools, tow hook, tire iron there, and where we're going to be working is right up and to the right here. All right, so we're going to be threading this cable through this boot right up here. All right, let's see where we're at on the other side. So we just want to make sure we have enough length. We want to be able to secure it. And then we'll pass this down there so that we can land pull a little bit more through. Gives us, looks like we got plenty of cable down there for right now, so we'll leave that there. Now we'll push through our alternator harness. All right, we've added our ring terminals to both the alternator V positive and the V negative, and we are using heat shrink terminal connectors, so we'd strongly recommend this because these are going to be mounted on the alternator, which is going to be exposed to kind of like road elements and stuff, salt, if you're driving through the rain, you know, water's gonna be splashing up there, so definitely recommend using some sort of heat shrink just to cover up those terminals and that connection, keep it from corroding. Okay, so this is our B positive post. This is where we're going to be connecting our 4-aught cable as well as our alternator B positive. We'll tidy up these cables once we've got everything secure. Now we have our harness back here. This is the pigtail, and this is where we have our blue and white wire with that Delphi connector, and that's going to connect in just like this. And then for our negative, should be, yeah, there it is. This is a 6mm hex key, and so this is where we're attaching our thermistor. It's going to assess the temperature of the alternator case, and then the alternator V negative, because this whole case is grounded, which is grounded through the chassis via the engine. So we've got this bracket and everything. This whole thing is acting as a ground. All right, now we got a lot of wires hanging here. We're just gonna wanna make sure we're routing these somewhat appropriately because we do have some exhaust heat shields right here. We're just gonna make sure we're trying to keep our cables away from that. And we've got all these wires hanging down here, which we will use. Those zip ties are gonna come in handy. We'll just pull everything up from the top and then come back down here and do a little zip tying. Get everything nice and organized. All right, guys, we got our cable run all the way to the back. It's kind of a mess. It's, like I said, it's not going to be properly routed. If you want to route it underneath along the chassis or inside, that'll be up to you. This is mainly just to get this to the back here. So we've got our main 12-volt power cable. This is connected at the alternator, and then our alternator harness here. And now what we need to do is put in a 15-amp fuse on our blue field wire. So we're going to isolate this out. I'm choosing to put it pretty close to where it's going to connect to the Zeus. That way I know right where it is. I'm just going to clip this here. We've got our 15-amp fuse in here. All right, we'll come back and we'll heat shrink both of those. All right, guys, we got our alternator harness all wired in here. That's going to be this one with a round plug. We're just going to let that hang for right now. Next up, we're going to be working on the battery harness. And since we're going to be pulling the battery data from the RVC network, that's going to be temperature, it's going to be current in and out, the voltage that the batteries are reading. We don't need any of these wires. We're actually going to be focusing on 3 wires: red, yellow, and brown. Red and yellow are going to be our positive and negative, respectively. Those are going to tie into our distribution panel over here. And then the brown wire is going to be our ignition wire. And since we already have a DC to DC charger running to the back here, this is actually our ignition turn on, and we can actually come right off of this terminal here. So that's where we're going to be running our brown wire to. And then our red and yellow are going to be coming over to our distribution panel, where we've got our 5 amp supply fuse already mounted right here. Then once we get those in there, we're able to actually plug in both connections and power up the Zeus, and we'll start the programming. All right, we've got our ignition sensing wire all tapped in. We've got our 12 volt positive and negative tapped into our distribution panel with our 5 amp fuse. So we're ready to start plugging things into the Zeus. One thing I do want to make note of is that these cables are currently just coiled up while we're getting everything loaded up and programmed just to test everything. Later we'll come back, we'll shorten these cables with some butt splice connectors, just because it's generally bad practice to have a bunch of cable looped up like this. This creates a bit of an inductance, can give you electromagnetic interference and or build up a lot of heat in the cable. So don't do this, especially with higher power lines. For instance, these 12 volt ones. This ignition one is just a sensing line, so not as critical, but still bad practice. So what we're doing here in this video, ignore that. This is mainly just to get everything connected. And in particular, this field wire, definitely try and not loop that, especially up near the alternator. You kind of want just like clean, straight cable runs for everything. So we'll get our 2 connections here, our battery harness and our alternator harness. And our Zeus. And so the alternator harness is going to plug into this twist lock connector here. The battery harness is going to plug into here. And then we do have a CAN bus RJ45 connection. So if you have a battery that speaks RVC or speaks the Victron BMS protocol, this is where you're going to plug in. And then this, alternatively, there is an NMEA 2000 port right here, just a 5-pin. This is where all the battery information is going to be coming in. And so we have these smart lithium batteries here from Go Power that do have an RVC connection, and we've kind of bootlegged our own connection here using some Wago connectors. And so when this plugs into the Zeus is going to be talking on, well, for these connections, we have CAN high and low on the brown and white wire, and then the green and white wire is going to be our ground. And so we have the corresponding CAN high, CAN low, and ground wires coming from the RVC network. This yellow wire here is a positive 12 volt signal from the Go Power batteries. But we have our data lines and our ground reference coming from these 3 connections, properly pinned to the correct RJ45 connection here. And so we're going to set this here, and this is where we're going to be plugging in. So now we'll have battery information coming through when we open up the app. We'll have our alternator connection here. There we go. It only fits one way, so once it slots in, we'll secure it with that twist lock. And then the battery, this is going to be a bit easier. And immediately we got a purple light. So on the Zeus, we have our indicator light here. That's going to tell us the status. And then we open up our app and go to Arco Zeus. All right, so we'll open up our Zeus app, and you can see that we've got the Arco Zeus here connected. Occasionally you might have to hit the plus sign in the top right corner like this and say begin new setup. We'll do that now just to run through. So this gives you kind of the rundown, choosing a default profile. You definitely want to make sure you're entering in the correct information because it can cause catastrophic failure to either your batteries or your alternator. So this has all of the information that you're going to need for installation. And so since we have this all wired in, we're going to kind of skip ahead here and get to the good part where it asks about your alternator manufacturer. So we're going to choose ARCO because that's what we're using. And we're looking for the A275L, first option. Battery manufacturer, we'll see if Go Power is listed. I don't see it in here, so we'll just say not listed. Battery model not listed. Battery type, we're going to go lithium iron phosphate or Life PO4. Hit next. So we have a 12 volt system. Our battery voltage is 12 volt, and we have 2 batteries in parallel. We do have a P-type alternator. Our tach poles are 16. This is pre-populated based on the alternator that we chose. Our drive ratio, so we have the Technique kit with that pulley and the ARCO Zeus, or ARCO A275L alternator. So in order to calculate that, that's going to be 160 millimeters for the Technique pulley, and then you're going to divide that by 49 millimeters, and that actually comes out to 3.26. So we're going to hit set. Battery info, amp hours, since it didn't have the model in there, we have a total of 600 amp hours. Our max charge current is going to be 1 times the capacity, so 1 times 600 amps. However, what we want to do is use the lower of the 2 values, whether it's the alternator or the battery bank. And so this we're actually going to set to the limit for the alternator. So this is actually going to be our max charge current from the alternator. And we are going to go with 250 amps here. Our shunt, 500 amps. Shunt rated millivolts, this is going to be 50. We'll skip ahead here since we have this all wired and we've covered that. In here you'll also notice there is a complete wiring guide for alternator and the battery, for the alternator harness and the battery harness. We've got our fuses already set. Again, this is stepping through each of the steps. So here's our alternator. Regulator, ARCO Smart Regulator has popped up. We'll hit connect. Should get a green check mark. There we are. We'll hit next. It's going to do a firmware check. We have the current firmware version 1.28 at the time of this video, so we'll hit OK. Hit next. Just a quick review of our charge settings. Minimum voltage 10, maximum voltage 16. We can edit this. All of these values are editable once we get into the app. And then our alternator settings, max operating temp, you'll see we've got a bit of a red error here. So this, our max operating temp is actually going to be 212 for this alternator. Our max absolute temp, this is going to be 230. Min engine RPM. So what I really like about the ARCO Zeus in general is that you can set RPM limits. And so let's say that you wanted to edit this graph so that you don't have the potential for 100% field when this thing is at a low idle. You can drag all of these little green dots down and kind of build your own RPM curve. And so as this goes up, you can, you have more power in the higher RPM ranges. So you can kind of drag these green dots, and then maybe when you're really on the gas, you don't want the alternator taking away from power, so you can drag these green dots down like this. So your max power is going to be in that kind of cruising range, 2,000 to 3,000 RPMs, and then as you start to really get on it, if you want to get up and pass, or you're maybe cruising up a mountain, you can scale each of these individual dots down so that you're not taking too much power away from the engine while you're up in the mountains or trying to pass. So we'll set an RPM curve, something like that. Hit set. We have our 0% duty minimum. Our maximum duty is 100%. We'll go next. We've got an invalid setting. Max absolute temp is invalid. Let's go back up here. We have a very narrow range, min of 248 and a max of 257. So I suppose we'll set it for 248. There we go. We're going to go with a default pin of 1234. It's going to send these settings to the regulator. Now we can go to our overview, our main screen. And so you'll see that our volts here and our amps, previously these were showing the RVC data. So we need to go in, we need to view the device, hit the top right corner, we're going to hit the top right settings gear. It's going to ask us for our pin. We'll unlock that. And since we are using the RVC network here, we're going to click on Regulator. We are going to, I guess we need to enter in our pin again. I'm going to click on Regulator. We're going to scroll down to Sync Mode. And we're going to click on Sync Mode, and we're going to look for Go Power. And there's Go Power. Click the X, and now we'll hit Save. We should see the RVC data start to come across. You can see the battery volts. I mean, for some reason it's kind of slowly climbing here. There we go. All right, so it's collecting the battery information from the RVC network. We have minus 1.4 amps. Looking at our display, that is correct. We've got battery volts getting into range here. It should be about 13.2. Currently showing 13.1. There we go. Waiting for the app. There it is, 13.2 volts. We have our alternator temp showing at 68 degrees. And so you can go in and you can actually edit a lot of other things from here. So we have this information we entered at the very beginning. Minimum voltage of 10, maximum voltage of 16. Honestly, that's going to be a little bit high for this battery system. 15 volts is a little more accurate. We'll click Save. And that green check mark always lets you know that the information has been passed to the Zeus and it has saved. Now the alternator information, you can have a delay, a startup delay. So once the ignition is sensed, it'll wait 30 seconds before it actually starts applying a field and you start charging. And then the ramp to bulk is before it gets to its max charge rate, there'll be another 30-second delay. Since that is all pre-populated based on selecting A275L from the beginning, we'll come take a look at the charge profile. And so this, you'll want to follow the recommendation depending on your battery. You can set these parameters based on your battery. And this is going to be important. You want to make sure these are correct per your battery manufacturer when you load these in, especially if you don't have a data connection. If you do have a data connection, the battery is going to tell the Zeus what it's looking for in terms of voltage and current, and the Zeus will scale to what's being requested by the batteries. If you do not have an RVC or a smart battery that's going to have, the BMS telling the Zeus what to do, you really want to make sure this charge profile is set up appropriately per the manufacturer. So we're going to leave that just as it is. We're going to save. So we'll back out to our main screen here. We can see we've got a battery temp of 68 degrees. The alternator temp is also at 68 degrees, which makes sense since we are parked in the same area and they've been in the garage all night. And so now, last thing to do, we'll test this out. We will start the van. We can take it for a quick little test drive, and then this screen should update based on how much the alternator field is. It'll show us what the engine RPM is, and we can see what we're charging at based on this little battery amp screen. This is another good screen you can watch. So it's currently in standby, and then this little down enter arrow looking thing is showing ignition disabled. So that's telling you why it's in standby. If this were red, that would tell you what the fault is. Maybe the ignition's disconnected, or the temperature is too high. So this is good information. You can tell right from the screen exactly what's going on. So once we start this up, it should be getting into either float or bulk charge, whatever mode the batteries are asking for. All right, we've started the van up. We're currently sitting here idling. Per the TAC, we're about 750, maybe 800 RPMs. And as you'll see on the Arco Zeus, we are currently showing 800, 850 RPMs. Just checking that first because that's actually telling us that our drive ratio, that 3.26 number that we entered, we are pretty accurate with that. Our duty percentage is currently 29%, and we are charging at 95.5 amps. So we're in the bulk charging mode. You can see here, bulk charging with the right arrow going to constant current. So our voltage has jumped up from 13.2 to 13.5. And we're charging about 100 amps just sitting here idling. So temp has gone up to 72 degrees. Everything's looking good. Slowly building on some amps, and so we'll take this out for a quick little spin and see what we get in terms of total charge. All right, we've started the van up. We're currently sitting here idling. Per the TAC, we're about 750, maybe 800 RPMs. And as you'll see on the Arco Zeus, we are currently showing 800, 850 RPMs. Just checking that first because that's actually telling us that our drive ratio, that 3.26 number that we entered, we are pretty accurate with that. Our duty percentage is currently 29%. And we are charging at 95.5 amps. So we're in the bulk charging mode. You can see here, bulk charging with the right arrow going to constant current. So our voltage has jumped up from 13.2 to 13.5, and we're charging about 100 amps just sitting here idling. So temp has gone up to 72 degrees. Everything's looking good. Slowly building on some amps, and so we'll take this out for a quick little spin and see what we get in terms of total charge. All right, now that we got some RPMs building, we're up over 100 amps charging, and we're about 2,000 RPM, no, 1,500, 1,600. It's only doing 24% duty, doing about 100 amps. The alternator is certainly capable of more, but it may be that the batteries aren't looking for anything more than 100 amps right now, so it's limiting the current to around that 100 amp mark. All right, guys, that wraps up our alternator regulator install, wiring in, and programming. If you have any questions, give us a call, 888-929-3149, or hit us up at customer support at RackUp+Go.com. If you're looking for a secondary alternator for your build, hit us up. We're happy to help you and point you in the right direction. And remember, life's an adventure, rack up and go.